Alright, welcome to this episode of How Do We Pass Our Common Core Algebra Regents. And as promised, we are going to solve system of inequalities. Alright, so right now what I'm doing basically is teaching you the mechanics of this. Then when we look at word problems, it's gonna get nasty, nasty. So here, the slope is negative 1 over 1. Oh my god, yeah, don't do it, Becker, don't do it. Yep, I did it. Negative 1 over 1. And the y-intercept is negative 2. So, is it going to be a solid line or a dashed line? It's going to be a solid line because it's less than or equal to. So, I'm going to go to negative 2 on the y-axis. And then, I am going to, let me see, oh my god. And then I'm going to go 1 down and 1 to the right. So, 1 down, 1 to the right, 1 down, 1 to the right. Or 1 up and 1 to the left, 1 up, 1 to the left. I got enough information. Okay, so now my line is going to be solid, so I have no worries. Look, solid line, hopefully. Oh my god, I'm running out of ink. Alright, now for the next one. The next one is also going to be solid. You see that? And I showed you how to do it on the calculator, but I'm going to show you the system. So the slope is negative 5. So negative 5 over 1. And the y-intercept is going to be positive 2. So I'm going to start at 2 right here. And I am going to go 5 down and 1 to the right. 1, 2, 3, 4, 5, and 1 to the right. 1, 2, I cannot, but it doesn't matter. I already have the 2 points, you see? This right here is the point that they have in common. Ah, no sé, creo que lo dejé afuera. No, afuera no creo que lo dejé. Why am I speaking Spanish? We're talking about the dog. Okay, so 2 solid lines. Now, what's going on here? So I found my solution? No, Becker. You see, this is one of the things. This is the difference between a system of equations and a system of inequalities. So in this case, I am going to go ahead the extra mile, and I'm actually gonna graph it. I'm gonna y is greater than, okay, or equal to negative 5x plus 2, and this line is called y is less than or equal to negative x minus 2. So now we know the labels. This is ugly, so I'm going to rewrite it. Y greater than or equal to negative 5x plus 2. Alright, so how do I find a solution? Remember, in a system of inequalities, you have to shade regions. Okay, so, well, let's shade them. And the region that is double shaded is going to be your solution to that system of inequalities. Okay. Kobe, can you stop walking over here and just like go away? So let's see. Y is less than. So we're talking about this one, less than. So remember what we said. If it's less than, we shade below the line. And make the lines long, long, nice, beautiful. All right. And the other one, it says y is greater than negative 5x plus 2. Greater than. Well, I see that the line is kind of like going down, but it's also going down to the right. So that means that if the line was a little more over here, this would be the bottom part, and this would be the greater part. So since I have y is greater than, then that's what I'm going to do. I'm going to shade the greater part. So this one gets shaded. Like that. Now, all you have to look at is where is the shading happening more than once. You could see that this area right here, okay, is shaded more than once. See, with the purple and the green. So my friends, this area right here is your solution. So what do? You write solution. And if they ask you for a point, you choose a point. Any point here, like 2 comma negative 5 will be a solution. Okay? There are infinite solutions to this system of equations. All right, let's try another one. Okay, this time I'm just gonna go straight forward, but you still need to write down, for security purposes, what is the slope, what is the y-intercept. So y is less than or equal to is gonna be solid, and I'm gonna shade below the line. 1/2 is the slope, and the y-intercept is 2. So I'm gonna go to 2 because that's the y-intercept, and the slope is 1/2. It's positive, so it's gonna go up 1/2. Up 1 and 2 to the right. Up 1 and 2 to the right. Or down 1 and 2 to the left. 1 down the left. And now you just graph it. Is it gonna be solid? Yes, we said yes. So look. Okay, better. All right. And now let me label it before I lose track of what I was doing. So this is y less than or equal to 1/2 x plus 2. And the other one is going to be y is less than negative 2x minus 3. The y-intercept is negative 3, so I'm going to start at negative 3. And the slope is negative 2 over 1. So that means 2 down and 1 to the right. So 2 down and 1 to the right. I could already graph my line with these 2 points, but I'm going to try to be more exact. So 2 down and 1 to the, let me see, 2 down and 1 to the right is the same thing as 2 up and 1 to the left. 2 up and 1 to the left, 2 up and 1 to the left. Okay, I got more than enough. Now I got more accuracy. Okay, good. Just remember something. The lines intersect at this point, but this is not the solution to this point, and I just made a huge mistake, so I'm gonna have to correct it, and I don't know how to correct it. The lines, this line was supposed to be dashed, as I said before. So if you corrected me, please, thank you very much. Look, dashed. Sorry, I'm gonna pretend that I'm still doing it, and is dashed. Sorry, is dashed. Okay, like this. All right, I'm sorry I made a mistake. I'm gonna try to correct it in the next one. But thing I wanted to talk about, the solutions. So on the green line, y is less than or equal. So I am going to shade where y is less than or equal. So down the line, below the line. See that? And now on the other equation, it says that y is less than, okay, on the green one, no, on the purple one, it says that y is less than. So on the purple one, y is less than. So this is above, this is below, so I'm gonna shade below. Okay? So now when they ask me where is the solution? Well, the solution happens in this area. Look, this is the green line, this is the purple line, and this is where the areas are shaded more than once. Any point in here will be your solution. Let's do another one. Okay. Well, in this one, the equation is already solved for y, but if not, remember you solve it for y. All right. So look, they're gonna be dashed because it doesn't have the or equal to. So let's start with the first one. I start at negative 2, and I'm gonna go 1 down and 1 to the right. So okay. And remember that they're gonna be dashed. So let's see now. This time I'm not making the mistake. Okay, so I think this should be enough for that line. And now for the other one, it says y is less than negative 5x plus 2. So it's still going to be dashed. The y-intercept is positive 2. And then I'm going to go 5 down and 1 to the right. So 1, 2, 3, 4, 5, and 1 to the right. And that's as much as I want to go. I cannot go anymore. And now I'm going to trace my line. So we got this. Sorry. It's dashed, okay? Dashed. You know what? This is too far from me. That's why. Okay, we're supposed to be dashed. So please, bear with me. Making too many mistakes now. Okay, so they both dashed. And now let's, one thing I'm not going to make mistakes on is in the solution set. So, here it says that y is greater than negative x minus 2. So, this line right here, since it's greater than, I'm going to shade above the line. And on the green one, it says y is less than. I'm going to shade everything that is less than on the green one like this. Okay, now we're good. So then now we look for the area that is shaded more than once. And we could see that is this area right here. Right here, this area. Any point on this area is going to be a solution to your system of inequalities. Good? Alright, so now let's compare that with the answers. So we see that both lines are solid. Okay? And your solution is this area. Next one. My God, I should have just looked at the answers. So we got one line that is solid, which that will be the top inequality, and the other one that is dashed, which is the bottom inequality because it doesn't have the or equal to. Okay, then we're going to compare it to this one right here. Okay, I said that both lines will be dashed, although I only dashed one of them, but hey, both lines are going to be dashed, and the solution is right here. See that? Alright then, so now I want you to try the following. Okay, if you need graph paper, just ask. If you're not my student, then you just have to have it ready. So, graph this. All I'm going to say is that this line is going to be a vertical line and it's going to be solid. And this line is going to be a dashed line. And then you already know how to do it. Okay, you pause it, you do it, because I want to go back to the first system of equations. This one. Let's say you are working on the calculator. So you press y equals, you go, okay, you clear everything that's there. Okay, and now you go all the way to the left, you start clicking enter until your inequality appears. So you have the less than or equal to. In the calculator that you have, you might not have these choices. You might only have the little symbols. So it's going to be negative x minus 2. The other one is going to be greater than. No, what's going on? Okay, sorry, just this. Or I think it was this, I don't know. It was greater than or equal to, okay? So enter. Enter. And now we put the inequality. So it's going to be negative 5. Negative 5x plus 2. Okay, now we graph. And look at what's going to happen. Boom. And then the other line. Boom. The area that is shaded twice, that is your solution. Got it? Alright, cool then. So this is the end for system of inequalities. So we'll cover a lot. On the next episode, we're going to be looking at, absolute value equations and graphs. Okay? Cool then. Okay, so now we're going to, in this episode of how do we how do we pass our Common Core algebra regions, we're going to start solving absolute value equations. But first, let me explain to you what absolute value, just in case you did not see it in 7th grade or 6th grade. So the absolute value of a number, let's say, first let me tell you what it is. The absolute value of the number 3 is 3. The absolute value of the number -3 is also 3. What? Yes, the absolute value of a number is always positive. Why? Because absolute value measures distance, okay? Like, for example, if you travel from New York to Washington and it's 500 miles, let's say you travel back from Washington to New York in reverse, you're not traveling -500 miles. You're traveling 500 miles. You're just coming back, okay? So now, when we talk about variables, let's say you have the absolute value of an unknown number. By the way, these bars denote absolute value. So let's say the absolute value of x, any number, is 9. Well, what does that mean? What can x be? Well, x can be 9, okay? Or x can also be -9. Because the absolute value of -9 is also 9. Get it? Okay then. So now, what would happen if actually we had the negative absolute value of a number? Let's say 3. Well, think about it this way. Think of the distributive property. So yes, whatever is going to come out of the bars is going to be positive, but there is a negative waiting outside for him. So then, guess what? The absolute value of 3 is 3, but then we're gonna multiply the negative. In other words, it's like if you put parentheses around it, okay? So then negative times this, okay? The absolute value of 3 is 3, and then distribute the negative and you get -3. As simple as that. So when the absolute value is on the outside of the bars, then yes, when the negative is outside the absolute value bars, then your value will become negative. As simple as that. But doesn't mean that it's negative. It means that whatever came out is positive, but then you have to multiply by a negative. Now let's do some damage. Let's solve absolute value equations. The first one, let's say we have absolute value of 6m equaling 42. So what does this mean? This creates two scenarios. Okay, one where you just write what you see, 6m equaling 42, and the other scenario where you have the thing inside. Remember the negative of this, just like the absolute value of 3 is 3 and the absolute value of -3 is 3, so you gotta have this negative. So it's gonna be negative and whatever you have inside the absolute value bars, which is 6m. Why did I put parentheses? Oh, because of the negative. -6m equaling 42. All right. So now let's solve the two cases. All right. So we divide by 6 because you already know how to solve regular equations. So m becomes 7. Now here you have to distribute the negative. So in reality you have -6m equaling 42. Now we divide by -6 and we get m equals -7. So what is the meaning of this? Easy. You have to check. So we're gonna replace the answers that we got. So let's put 70 here. So 6 times 7 is 42. Absolute value of 42? 42. Good, it checks. Now let's try this one. We got -7. So we're gonna replace -7 over here. So 6 times -7 is -42. The absolute value of -42 is 42. So it checks. So these are your answers. So the answer is 7 and -7. Got it? Okay. Let's do another one. Let's have, let me see, something a little more difficult. Okay, let's have 7. Let me try in a different color. So, you know, it's a different problem. Duh, I'm not saying that you're not smart. I'm just saying. So 7 times the absolute value of n, okay, equaling, I don't know, 56. Okay, so how do I solve this? Well, before you create the two scenarios, notice that you have something outside the absolute value. So you need to get rid of that. You need to have the absolute value expression by itself. So we're going to divide by 7. Okay? So when I divide by 7, I get absolute value of n equaling 8. 56 divided by 7 is 8. Okay. Now the absolute value is by itself. Now we created two scenarios. One where we just write our regular expression, and the other one where we write the negative of our expression. See that? Now, funny thing is that I forgot to tell you here. If you want to, you could just from here you could have just divided by negative, and you would have 6m equals negative 42. This would have become positive, and you didn't have to go through all this. But anyways, I'm gonna do it here. So n is 8. There's nothing to do here. Negative of n is 8. So we have negative n equal 8, right? Or I could just divide by the negative. Okay, if I divide by the negative, let me divide by the negative just for the sake of doing it. So, or negative 1 if you want to. I really don't care. So the negative n becomes positive, and the 8 becomes negative. I hope you understood what I just did. So now we have two values. Now all I have to do in order to check my equation is replace it in the original. So here, the absolute value of 8 is 8, okay? Times 7, 56, it works. Now, the negative 8. The absolute value of negative 8 is still positive 8. Times 7, 56, it checks. Boom. So you have your answers, 8 and negative 8. Okay, let's do another one. Let's say I have 4 times the absolute value of n plus 8 equaling 56. I love that 56, right? Okay, how am I going to solve it? First of all, the absolute value is not by itself, so I have to divide by 4 on both sides in order to leave the absolute value. So I'm going to divide by 4. Divide by 4. Divide by 4. So when I divide by 4, this cancels out, leaving you with absolute value of n plus 8. And now you gotta divide 56, okay, by 4. What is 56 divided by 4? 14. Alright, the absolute value is by itself now, and now we created two case scenarios. One where we just have the regular equation, and the other one where we have the negative of that expression. Alright, so now I can do two things. I can distribute the negative right here. So negative n minus 8 equals 14. Or I could just divide by the negative to make this positive. Okay, or multiply by a negative. The idea is to get rid of this negative. So I'm going to do it right here. Hopefully you understand. So I'm going to divide by the negative. Divide by negative, divide by negative. And what you have now is negative divided by negative is positive. So n plus 8 remains the same. On the other side, 14 divided by negative makes it negative 14. And now we subtract 8 from both sides using the additive inverse, and we get negative 22. Okay, so now we have this solved. I forgot to solve this one. So here I'm going to subtract 8 from both sides, and I'm going to get n equaling 14 minus 8 is 6. Okay, so I have the two answers. So all I gotta do now is to check is I replace this, I substitute this into the original absolute value equation. So let's see, 6 plus 8, 14. 14 times absolute value 14, 14 times 4, 56. Negative 22. Negative 22 plus 8 is negative 14. Okay? Yes? I don't know. Let's see. Yeah, negative 14. And absolute value of negative 14 is positive 14 times 4, 56. It checks. These two are the solutions to your absolute value equation. All right, let's do more damage. And I showed you that you could just divide by the negative, but on the next examples, if I have a negative, I'm just gonna distribute it, okay? To show you that it's the same thing. All right, absolute value of m divided by 5 is 3. So what do I know here? I know that the absolute value is not by itself. The whole thing is not within the absolute value bars. It's just the m. So the 5 is dividing the variable. So what am I gonna do? I need to get rid of this denominator. How? I just have to follow the golden rules. Remember, is there a distributive property? No. Are there any fractions? Yes. So multiply by the common denominator, which is 5, or 5 over 1, however you want to look at it. So here the 5s are going to cancel out, because when you multiply and divide by the same number, they cancel out. So leaving you with absolute value of m equaling 15. Okay, now you go with the 2-case scenario, which basically this is easy. Okay, absolute value, so m equals 15, and the negative of m equals 15. M is 15, is already done. Here m cannot be negative, you cannot have a negative answer, so multiply or divide by a negative to change the signs. So if you divide by the negative, you get positive m equals negative 15. All right, questions or comments, you could always do that. Let's do another one. You see, I want to make sure that you understand this perfectly. All right, so let me see now. All right, change ink so this doesn't become dry. Okay, here, x over 7. All right, notice that now the fraction is inside the absolute value. Equals 5. All right, so what am I gonna do? Well, nothing. The absolute value is by itself. So now you create your 2-case scenarios. One where you just copy the original, and the other one where you use the negative of your original. Okay, so here, nothing more, nothing less, just a one-step equation. So you don't have distributive property, but you have fractions, so you multiply by the common denominator, which is basically 7, okay, because it's 7 and it is a 1. So multiply by 7 on both sides. So this cancels out, and you got x equals 35. Here you have negative, how can I put this? All right, let's see if you understand this. No, you know what? Let's forget about it. Let's have it like that. All right, so I distributed the negative, okay? So now I don't have distributive property, but I have fractions, so I'm going to multiply by the common denominator. In this case, is 7. So it's the same thing as here. So when I multiply by 7, okay, I'm going to get negative x equals to 35. But then again, the x is negative. You don't want to have a negative x as an answer. So you divide by a negative or multiply by a negative to change the signs. Or just divide by -1. I really don't care how you do it. There you go. And you have your 2 answers right here. Okay. So this is basically solving absolute value equations. I want to see, I mean, is there anything else? Any other problems that I see? No. Okay, so then I'm gonna write a couple of them so you could solve them. All right. Okay. So I'll try them. So here You have to get x equals -5 and x equals 5, and then you substitute to see if it checks. Here you're gonna have again -5 and 5. Alright, so here you're gonna have 9 and -9. So m equals 9 and m equals -9. Alright, so I provide you with enough practice. These are your answers. If you have any questions, you could comment, or if not, then just ask me a question if you're my student. Okay, so now we're going to move on to something called graphing absolute value equations. What is it that I want to do? Well, first of all, I want to graph an absolute value equation. So what is it that I want? Well, let's talk about the parent function, the main function. The absolute value function looks like this. Y equals the absolute value of x. That's the main function. That's where all the other functions are going to come from. So how do I do this? Well, first, let's create a table of values for your by hand, right? Let's create a table of values for this graph. So I have y equals the absolute value of x, and I'm going to create a table of values by hand so you can understand what's going on. Y equals whatever, the absolute value of x. This is y, and this is x comma y, your order pairs. You don't have to do all this. Just want to make sure that I am on the right page. Okay, so let's see now. I'm going to give values. Let's say I want to give values like starting from -3, -2, -1, 0, 1, 2, and 3. I went overboard with this, but meow, 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 psh, caught you. And then meow, meow, meow. Oh, okay, good. It looks a very, very disgusting graph, and guess what? I don't care. So let's talk about it. So when x is -3, so what is the absolute value of -3? 3. When x is -2, what is the absolute value of -2? 2. When x is -1, what is the absolute value of -1? 1. When x is 0, what is the absolute value of 0? 0. Absolute value of 1? 1. Absolute value of 2? 2. Absolute value of 3? 3. It's always positive, right? So now my order pairs are going to look the following way. Listen, once you know how to graph something, graph points, you know how to graph everything. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Okay, so now let's graph that. So remember the point. Oh, okay, right here. So let's see. -3, 3. -1, 2, 3, 1, 2, 3. Okay. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. You see that? This is the shape of an absolute value function. Now let me connect the points. You see what it looks like? Okay, so it's the shape of a V. Okay, if you were to describe this, you would say that this line is a reflection of this line over the y-axis, or that this line is a reflection of this line over the y-axis. Okay, it's a reflection over the y-axis. As simple as that. Anyway, so this is your function graphed. Now I'm going to show it to you on the calculator. All right, just in case. All right, so press y equals. Now clear everything that you have in there. So I'm just going to reset the calculator because I don't have time to do all this. Okay, good. I reset it. Now going to y equals. Can I make this brighter? Yes, I can. Nice, beautiful. Hopefully you can see it. And let's graph the absolute value function. So you are going to press alpha window. Okay, alpha window, and you see where it says absolute value. Well, that's on this calculator. On the other ones, you press. Let me see. On the other one, I think you press math. You go to the. Right, and you see the absolute value there. So you enter it. Anyways, the absolute value of x. Let's graph it. Psh. Boom. See, it bounces back. Okay then. Now, let's look at some transformations that happen in here. Where is the vertex of this graph? The vertex is right here at a minimum. It's at 0, 0. You could see it. Okay? So it's the same thing as when we were graphing quadratic equations. Now that you understand a little bit, I'm going to explain to you. This x minus 1, just like in the quadratics, it creates a shift, okay, to the right. Remember, the absolute value function, let me just write it over here. It's like this. Y equals to the absolute value of x minus h plus k, where h comma k is the vertex. Okay? And k is a shift up or down, like the y-intercept, right? But it's a shift up or down. I'm not saying that this is the y-intercept. All right. So let's see what happens. Let's graph it. Let's compare each and every single one that we're going to graph to the parent function. That's why I put absolute value of x. So this one was what? Absolute value of x minus 1. So look, the blue one is the parent function, the original. And now look at the red one. Is shift 1 unit to the right. Okay, so that's okay. Now I'm interested in the red one, right? So let's take a look at the table for the red one. So you press second graph, and we have values. Okay, see, I didn't lie. Negative 3, 4. Negative 3, 4. So that's what I'm gonna graph. Negative 3, 4. 1, 2, 3, 4. Then negative 2, 3. You see that? Negative 2, 3. Negative 1, 2. 0, 1. Okay. 0, 1. 1, 0. 1, 0. 2, 1, 2, 1, 3, 2, 4, 3, and so on. You see, I graphed it. Okay. So I go this way, and I go, man, this thing is awful. Well, the marker is thick, that's why. Yeah, I kind of like, oh, nice, I didn't mess up. Put the arrowheads, you label it, and that's it. So you saw it shifts 1 unit to the, let me write it over here, vertex. Vertex. Nice. It would be 1, 0. Why? Well, the opposite of h right here, negative 1, is positive 1. But what about the 0? Well, you're not adding k over here, so k is 0. Got it? Good. All right, let's take a look at the next one, and next one, and next one, and we're gonna be Gucci. All right, what do I know about this? I know that this is going to be a shift to the right because it's the opposite. So I'm gonna have the point at 2. Okay, but yeah, but why here? Why not up and down? Well, look at the k. There is no k. It's 0. Oh, so the vertex is 2, 0. Yes, 2, 0. And why is it good to know about it? So I know that from here, I'm going to go this way and I'm going to go this way. Okay, so I just need 1 point from each. Let's say x is -3. -3 minus 2 is -5. Absolute value of -5 is 5. So I have -3, 5. So -3, 1, 2, 3, 4, 5 is right here. Okay? So if I look at it, I just have to connect the 2 points. And I get my v. Now I need a positive value. So let's have 3. So when x is 3, okay, what do I have for? Oh, let's say 4. 4 minus 2 is 2. Okay? Absolute value of 2 is 2. So 4, 2. So 4, 2 right here. See that? Okay. But it's always good to have the calculator handy. So let's see what's going on with the calculator. So I'm not gonna clear the parent function. I'm just gonna leave it there and I'm gonna create the other one. So absolute value of x minus 2. Okay, graph. So that's the parent function with vertex at 0, 0. And this is the other one. Look, a shift to the right 2 units and not 0 up and down. All right, now let's do one where we have a shift up and down. All right, here, let's analyze this graph. First of all, we have a negative outside the absolute value. Therefore, whatever comes out is going to be positive, but then it's going to turn into a negative. And here, we don't have a shift to the left nor to the right, but we have a shift going down. So my vertex here would be at 0, -1. Okay, so 0, -1. And if you don't believe me, don't worry about it. That's why we have the calculator. So we are going to erase, clear this function, leave the parent function so you can understand what the shift, how it's changing. All right, so what was it again? Negative, so the negative is outside. And then we put absolute value of x and then -1. Okay, so let's see how this changes. So this is the original, the parent function, and then the other one, what's going on? What? Yes, the value outside the absolute value is, the sign outside the absolute value is negative. Oh, Bags, you nice. So that means that, yes, the same thing as with the parabolas, okay? So it's a reflection over the x-axis. And I told you that the vertex was going to be at 0, -1 because it's right here. I understand it. So let's graph a little more about it. So let's go to the table and let's see -3, -4. So -3, 1, 2, 3, 4 at -4. Okay. -2, -3. -2, -3. Okay, I know what this is going, and I know that this is the vertex. So 0, -1, and then 1, -2. 1, -2. And you know how it goes. Once it turns, just follow the path. Okay, and now beautiful, right? So now you know that and let me write it again, in vertex form. So y equals a absolute value of x minus h plus k. All right, that is the true form right here. So now what happens is that a, just like in the parabolas, if a is a large number, whether positive or negative, right? If it's like a really large number, like 2, 3, 4, 5, 6, 7, or negative number, the like -2, -3, -4, then the graph is gonna be narrower. If the value of a is a fraction closer to 0, whether negative or positive, it's gonna become fatter, like that. Okay, and that's basically it. Let's analyze other graphs. All right, let's analyze this graph. What do I know about this graph? That it's going to open down, okay, because it's a negative outside, and that it will shift 2 units to the right because it's the opposite of this. The vertex is going to be 2, 0 because there is nothing being added. There is no plus k. All right, and let's look at it. Okay, that's what we're doing. You are graphing it. I'm just going to show you what it looks like. So negative absolute value, and if you don't have this calculator, don't worry. I showed you how to do it by hand, so haha. -2 is going to take you longer, but so let's see how this compares to the parent function. Parent function, boom, and now red one, okay, opens downwards, and it has the vertex at 2, 0. That tells you the turning point. That means that from there the graphs go separate ways. All right. All right, let's take a look at this one. What do I know about this one? I know that it's going to be negative, so it's going to open downwards. I also know that inside the absolute value, I have 2x plus 2. I know that there's going to be a shift going up by 4 units, but I'm not sure about it. Why am I not sure? Well, think of it this way. The way you know how the graph is going to behave is if you have it in this form. And what is this telling me? That the coefficient of this x has to be 1. But the graph that we have is actually y equals -2 times the absolute value of 2x plus 2 plus 4. This is where your factoring skills come in handy. We need to have this as a 1. So what we're going to do is we're going to factor out the 2. What? Yes, we can. So look at what I'm going to write. Factor out the 2. If I factor out the 2, I'm going to have -2 times 2, okay? Absolute value of, since I factor out the 2, it's like I'm dividing this by 2, right? So divided by 2 is x, divided by 2 is 1. I don't do anything to this one. So my new equation will be -4 absolute value of x plus 1 plus 4. Now I know that it's going to be negative, definitely, so it's going to open down. There's going to be a shift to the left by 1 unit, so -1. The vertex is going to be at -1, 4. All right? Please understand that. So -1, 4. That's the vertex. Let's see if it's true. All right. The calculator doesn't need you to factor anything. The calculator understands what you're doing. So I'm just gonna rewrite the new the original. So go to y equals. All right. I'm still gonna keep the parent function. Okay, absolute value of x, and I'm gonna put this -2. Okay, absolute value of 2x plus 2. Get out plus 4. Oh, okay. Now let's see how it compares to the parent function. All right, parent function, and now the other one is going to open that. It's going to be skinnier, as we said, and the vertex is going to happen at -1, 4. Look, -1, 4. -3, what? -3, -4. So -3, -4. -2, 0. Okay. 4, then 0, 0, and 1, -4. And that's my V right there. All right, let's try another one because this is getting fancy. So what do I know? I know that it's positive, so it's gonna, the value of A is positive, so it's gonna open upwards. What else do I know? I know that there will be, oh wait, I thought there was gonna be a shift to the right by 3 units, but actually the value of the coefficient of X is not 1, it's 2. So I have to factor out, okay? So it sucks not to have the answers in front of you. So I'm gonna factor out the 2. In other words, I'm gonna divide by 2. That's basically what it is. So now I have 2. Since I factor out the 2, that means that I'm multiplying by 2. Okay? That's basically what it is. So now inside the absolute value, what do I have? Well, 2x divided by 2 is x. And now minus 3 over 2, or 1.5. What? Can you do that? Yes, I can. You remember something. When you factor something out, you have to make the expression inside the absolute value equivalent to what it was before. I need 2x minus 3 inside the absolute value. So that's exactly what I have to write here in order to get it back. Look, 2 times x is 2x, and 2 times 3 is 6 divided by 2, 3. There you go. Now let's rewrite our new equation. Y equals to 4 absolute value of x minus 3 halves. Got it? Okay then, so now what do I know? Well, now you know something. First of all, the vertex, okay, the value of k is 0. We don't have something outside. All right, so it's going to be skinny. It's going to open upwards. It's going to move 1.5 units to the right because it's the opposite of 3 over 2. Remember? Okay then. So now let's have our equation right here. So when I did it, I wrote y equals 4 absolute value of x minus 3 over 2. And remember, you want the inside to be positive, like the coefficient of x. Okay, so that's what we have, and I wrote plus 0. So the vertex is at 1.5 comma 0. Let's see if it is actually true. Now you have the calculator, you could do it on the calculator. I just wanted to show you because they want to describe the motion. So that's how you describe it. Well, it's going to shift this, it's going to translate that, blah, blah, blah. Okay, so y equals, let us clear this, and let us write the original one. Okay, so it's going to be 2 absolute value, and then you have 2x minus 3. All right, and then that's it. So let's see how it compares to the parent function. All right, so we say 1.5 units to the right. That looks like 1.5, right? And there was 0k added, so the vertex is at 1.5 comma 0. All right, so here, what do I know? We know that this, if we want to know what the vertex is and how it shifts, we need this to have a 1. So what I'm going to do is I'm going to divide, okay, this thing by -3. Okay, if I divide by -3, what do I get? First of all, that means that I'm factoring out the 3. So I get y equals 2 times -3 times the absolute value of, and what do I have left in here if I divide by 3? By -3? X, 1x, right? And then here I get -4 over 3. So minus 4 over 3. Okay, and then minus 3. This is to identify the vertex, okay? And you could say the axis of symmetry. The vertex. by no means I'm saying that it's gonna open downwards. All right, so now what do I have? I get something like this, -6, okay. Let's see now. -6, absolute value of x minus 4/3 minus 3. All right, remember you're only working with this part. This is k. So now I know that it's going to shift 4/3, okay, 4/3 units to the right, because it's the opposite of this one, to the right. What's 4/3? That's 1 1/3. That's 1.3. Okay, so the coordinates for the vertex are going to be 1.33333, comma, -3. That's the vertex. And that's basically what I had on the calculator. If you look at it, okay, it's 1.3, comma, see that? 1.3, comma, -3. And let me see now. Okay, right here. 1.3333, comma, -2.99999, which is basically -3. All right, so you got it? Let's see, there's going to be some type of movement. It's going to be opening upwards, right? But this is not a 1. So what we're going to do, we're going to factor out what? Let's factor out the -3. So let's divide by -3. So what do I get? I get 3 times -3 times the absolute value of, what happens when I divide by -3? This becomes a 1, so 1x plus 1. See that? And there is no k, there is 0k, so plus 0. So now the vertex is going to be is going to have a shift to the left, It's going to shift to the left because it's the opposite of this one. -1 and then comma 0, and that's where your vertex is going to be. Let's take a look at it with the calculator. All right, dun, 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 dun. Okay, so let's take a look at it with the calculator. So I'm gonna graph the original 3, absolute value of, okay, -3x minus 3. Okay, that's it. So that's the parent function right there, and now it shifts 1 unit to the left and vertex at 0, and look, since the coefficient here is larger than 1, then it becomes skinnier. Got it? Boom. All right, now I want you to try this one, and that's the last one you try. Okay, so you tried it, and now what are you going to factor out? The 4, the -2, what? Exactly, the -2. So you're going to divide by -2, correct? All right, so then now your new equation looks like this. That's because you want to identify the vertex. Y equals -3 times -2, okay, times the absolute value of x, and then remember you're dividing by -2, so -2 plus 3. Yeah, you don't divide this by that. Okay, so now what can I say about this the new equation? It's going to be really skinny because this is going to be 6, okay? And from the beginning we already know that it opens downwards, all right? So even though you see it like this, it's still the original. Remember, it opened downwards. So here you write, okay, x minus 2 plus 3. This is not 21, this is 2. All right, so it's gonna move from the parent function, okay, it's gonna move 2 units to the right, and it's gonna shift 3 units up. And the vertex is at 2, 3. Got it? All right, so this was graphing absolute value equations. I showed you how to describe it, but it's always useful to use the calculator to create your own graph. Look at the table of values and graph from there, okay? All right, I'll see you on the next episode.